Okay, that's why you have to include the minus 48. So this is equal to minus 5 megapascal. Okay, which is exactly like what we have drawn. Okay. So the next thing that we're going to do, we're going to find the radius of the circle. Okay, we're going to find the radius of the circle. So the radius of the circle, we also know is our tau max. So tau max is equal to what? So what we need to do now is we have to sort out two values now. Okay, so we have to find the distance from here to here. So we need to find this distance, right? Oh, you guys, hold on, undo. Everything still look fine. So it's this distance that we need to find. Right? So that distance over there, okay, is 35. So this is 35, right? And then we need to find this height, the shear, right? And we know that this is 15, right? So why are we doing that is because we want to find this distance, okay? We want to identify this is our radius. Okay, so radius of our circle is equal to very straightforward formula. You guys will know this formula. This is equal to 35 squared, right? 35 squared plus by 15 squared. So 35 squared plus 15 squared, right? Square root is equal to 38.079. Okay, 38.079. That's our radius. So from here, we can also calculate our principal stresses. Yes or no? We can calculate our principal stress. So we are going to calculate our principal stress. Which is our stress 1 or stress 2. So stress 1 and stress 2 is equal to the center of the circle, which is minus 5, plus or minus the radius of the circle, which is 38.079, right? So this will be equal to minus 5 plus by 38.079 is equal to 33. Okay, so at one point, it's positive 33.079 megapascal. And the other point is minus 43.079 megapascal. Okay, 43.079. So from here, okay, so those of you that have your compass, you can start drawing your Mohr circle. Okay, so radius is 38. I'm eyeballing this. Okay, so 38. Okay, and then positive shear, or not, the one side is at 33. So 33 is somewhere around here. And the other side, I have to stretch to 43. Right. So this is your first Mohr circle. Okay. So this is your Mohr circle. What have we found now? Okay. What have we found now? So we have done the average normal stress. Right. We've done that. Maximum in plane shearing stress. We've done that. We calculate our principal stresses. So next we are going to determine our principal plane. Okay, so we're going to determine our principal plane. So our principal plane you can determine from point X or you can determine from point Y. It's all going to be the same. Okay, so this is equal to 2 theta P. Right? That is from point X. And from point Y, This is 2 theta p. Okay. Oh, by the way, I sincerely, so this over here, this is my stress 1. Okay. Over here where the shear stress is equal, this is my stress 2. Okay. It could go the opposite direction, does not matter. Okay. In stress 1 and stress 2. You want to call the left hand point over here to be stress 1, by all means do so. Okay. Will not harm anything. So now we're going to calculate the 2 theta p. So as I just mentioned, you can calculate from point X or from point Y, does not matter. So 2 theta p is basically from the element. We're going to rotate the element, right? To, or we're going to move point X or point Y to stress 1 and stress 2, where the normal stress, sorry, the shearing stress is equal to 0. So that's the definition of principal stress. So from here, we know that tangent 2 theta p will be equal to what? Will be equal to 15 divided by 35. Okay, so 2 theta p, 15 divided by 35, inverse tangent is equal to 23.2 degrees. And theta p is equal to 15.6 degrees. And you have to include the direction, which is what? Anti-clockwise. So if you rotate from point X, okay, it's anti-clockwise, like what this arrow show. You rotate from point Y, is also what? Anti-clockwise. So it does not matter you take from point X or you take from point Y, it's always going to be anti-clockwise, okay, for this case. So we have identified this point over here. So next, we're going to construct and label, okay, the element. So what I'm trying to achieve down here is this, okay. We know how to get from element to Mohr circle, okay. So the next thing is, can we extract from Mohr circle to element, okay, which you can, okay. So I'm going to show you how. That's what we are going to do now, is construct the element, okay. So I'm going to show you how to construct the element. So first of all, you draw the original axis, okay. So the original axis, okay, so this is the original axis I'm drawing now. Okay, it's the original axis. And then we know that it's going to rotate anti-clockwise by 15.6 degrees. Okay, so I cannot draw 15.6, I'm going to draw 16 degrees. Okay, so I'm going to construct 16 degrees. Okay, so this is about 16 degrees anti-clockwise. Okay, so this 16 degrees or 15.6 degrees. Okay, anti-clockwise. So it has to comply to the rotation direction. Okay, that's why the rotation direction is important. Then we're going to rotate this by, okay. So this is our principal plane orientation. Okay, so this is also rotated in the anti-clockwise direction. Okay, 15.6 degrees. Next, we're going to draw our element. Okay, so this element, when we construct, is at the principal plane direction. So there is no shearing stress. I repeat again, there is no shearing stress. Okay, so that is our element. Okay, a sketch. Then from here, I want you all to do a practice that we want to draw a vertical line up. So this is your point X, okay, and then you draw a horizontal line, right? This is your point Y, right? So why is this important? Then we know what is the stress value we are looking at, okay? So let's look at X now, okay? X, right? Point X rotate to the principal plane, right? And we know that this is also 15.6 degrees anti-clockwise. Okay. So like what I mentioned before, that's an element. On Mohr circle, hey, how do I get 15.6? I think I pressed the wrong number. 23.2 divided by, wait, 15 divided by 35. Sorry. 15 divided by 35, inverse tangent is equal to 23.2. So 23.2 divided by 2 is 11.6. Sorry, it's 11.6 degrees. I don't know why I call it 15 point. So 11.6. Okay, so this is my 11.6 degrees. I do apologize. Okay, so all these are my 11.6 degrees. Okay, and this one is also 11.6 degrees. Okay, 11.6. So from point X, it's going to rotate anti-clockwise, right, to 11.6. On Mohr circle, from point X, is also going to rotate by what? Rotate by 23.2. So this is your stress 1 value. And you know that stress 1 value is equal to 33.079. So it's in tensile. 33.079 megapascal. Okay, so now we look at point Y. Okay, on the element, point Y on the element will rotate anti-clockwise to this plane and is also 11.6 degrees. Right? So if you look at Mohr circle from point Y, you rotate by 23.2 degrees, you get your what? You get your stress 2 value. Okay, you get your stress 2 value. So your stress 2 value is equal to 33. Compression is equal to 43.079 megapascal. Okay, so from here what we just learned is now you can relate from Mohr circle, from the element to Mohr circle. So now you know how to relate from Mohr circle. So what you've just learned now, crash again. Hold on, people. Is back. Okay, is back with a vengeance. Hold on, I'm trying to look for my mouse now. New window. Bring up here. You can see it. I'm gonna zoom. Okay, so now what you can do now is you can also deal with from Mohr circle, right? We can draw your what? You can draw your element. Okay, so we can do both ways now. Okay, we can do from element to Mohr circle to element. Okay, so if you were to look at the math that's involved, it's really straightforward. It's not difficult at all. Okay, the math is so simple. But constructing the circle, okay, I want you to visualize where the stress state are on the circle. Now, I'm going to do something further. Okay, is now, what if now? Okay, so I'm going to hopefully, usually at this time it will not work, but I'll try to make sure that it works. I'm going to copy the same thing. Okay, and I'm going to paste up. Bear with me, okay? Right. So what I've done now is, okay, what if now, okay, let me get rid.
Sure, I just have a quick question.
Yes.
So did we say that the direction of theta p would always be counterclockwise?
No.
Okay.
For this case only. For this case only, not always. For this case only, because X to stress 1 is anti-clockwise. Okay. If let's say point X is on top, it will be clockwise. Does that make sense?
Yeah.
Okay. So just for this case, it's not always. Okay. Do not take it as an absolute, because every element